Yo, 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 what up? About to do another 30-day LeetCoding challenge. We're on day 3. Yesterday I did Go, even though I don't know Go. And hey, no Go. Not really a great idea. I think I probably should have started with a book or something. So today I think I'm just going to do JavaScript and just going to enjoy myself. So thanks for stopping by. So given an integer array, nums, we're going to be finding the contiguous subarray containing at least one number which has the largest sum, and we're going to return that sum. Wow, so that's an interesting problem. So what we're going to do is we're going to basically look at an array, we're going to add numbers up, and we're going to find the contiguous subarray which has the largest sum. So it might be the whole thing, it might be only one element, it could be 3 elements. So what's the easiest way to figure that out? Geez, I don't know. I'm gonna have to think about this a little bit. So, I'm trying to think, like, as a human, how would I do this? I definitely don't want to add up every combination, so that would be quite a bit. We have a hint here. If you figured out the O and solution, try coding another solution using divide and conquer, which is more subtle. So that's an interesting hint. You know, divide and conquer basically tells us kind of half the equation there. We'd be splitting that up, splitting it up, splitting it up, and then comparing everything. But I don't think we're going to go with that first one. I'm just going to try the brute force because right now I don't really know how to solve this. So if you have any ideas, please feel free to drop a comment or drop a chat. Is that what we say in Twitch land? I don't know that I've ever come across a problem like this before. So I'm just going to kind of try thinking about what I can do and see if I can bridge that gap somehow. So obviously I'm going to have to look at all the numbers. There's no way to avoid that. I can't tell you if this subarray is the greatest if I haven't even seen the numbers over here. So there's no way we're going to beat O of n. I can't sort the numbers because then I'd lose their position and I wouldn't be able to tell you what the subarray is. Now I could kind of keep a max, and as soon as I see something less than that max, then I can stop. That's not quite true. Is it? Yeah, that's not true. That is true. So I don't know how well I can explain that. Basically, if I'm adding up numbers and they are less than the current max, or rather if they change to less than the current max, then I know I can just stop. Because if that number brings it up past the max, then well, why don't I just start there, right? So that's an interesting tidbit. Not sure how useful that's going to be. But man, I'm feeling kind of stuck. Maybe it's because the coffee hasn't sunk in yet. But if you have any ideas out there, internet, I would love to hear them. Not giving up, though. I don't think I can do anything slick like just looking at finding the biggest number and starting from there. I mean, if I just iterated, if I just looked at all the permutations, then, I mean, looking at all the permutations would do it. All the combinations in order, But that just seems like a lot of extra work that I shouldn't have to do. But permutations isn't the right word because I'm not looking at, basically because it has to be ordered and contiguous. So, you know, that's not terrible. Also, thanks to, hey Gavin, what's up? I think what they're saying is basically we have to find the set of numbers that are next to each other that have the greatest sum. So what I could do is add these two numbers up together, add these three numbers up together, add these four numbers, add these five, and then start the next element. Add these two up, add these two up, add these two up. I don't think memoization would really help us a little bit other than, you know, I could kind of save a little bit of repeated math. But ultimately I'm comparing every number against every number over and over again. So we're looking at an n squared solution there, which always stinks. Just feels wrong. So I'll think about it for a few more minutes. And if anyone has any ideas, I'd love to hear them. Otherwise, I might just go with that solution and then go to work for the day. I don't know. Help me out here, Gavin. That's a large sum. And we only have to return the sum. Yeah, I don't really know. I mean, I could do some kind of creative caching. So like if I add up all these numbers and then I know I'm going to do this set next, I could do something kind of cool where I like, you know, basically subtract one number to reduce the calculations, which is nice. What I mean by that is like if I'm saying -2 plus 1 plus -3, I could drop out that -2 and now I've got the sum from here. So rather than adding up these two things, I could just do one subtraction, which seems like a minor optimization to me. It doesn't seem like that's really worth going after unless this thing is running too slow. It's just going to get sticky. It's going to make it harder to read, harder to type, and more edge cases, stuff like that. So we'll give it 3 more seconds, and then I'm just going to brute force this baby. 3, 2, 1. All right. Let's do this. What's the best way to start? I guess we'll just loop through the array, starting at whatever index, and we'll just keep a max. Or let I equal 0. I guess I could have done this with a for each, but I don't know. There's something about these old for loops that just feels like home. Oh my gosh. All right, I feel the coffee power kicking in. Feeling good. All right, what are we going to do? So we'll basically just keep a sum of the basically whatever we've, oops, and this is not equal to 0. This should be equal to I. And we'll walk through this in a second by hand and make sure that it's going right, but I think that's right. So what we're going to do is add Here we go. So we're going to start the sum at whatever our starting number is. Alright, so we're going to start with, in this case, -1. And then our j is going to be equal to +1. And then we'll add these numbers together and then continue. So what we have to do here is basically check the max in this loop. I think that's pretty good. So if my sum is greater than my max, then my max equals the sum. Alright. So in this first case, we're going to start with -2. That's greater than -infinity. And then we're going to set our max equal to -2. So doing good so far. And then we're going to come into this inner loop. We're going to set that index to the 1. And we are going to add 1 to our sum, which is -2. It brings us to -1. And then that should be the new max. So we're going to have to check this max down here as well. Okay, and then we'll continue. So now our sum is at 1, and we're going to add -3. So it's going to go down. So if we were being smart about this, we could surmise that this number has gone down from our previous sum, and so we don't even have to continue this train of thought. We could basically pick up from here and keep moving. And so I think I'm going to just add a little note, because I'm not 100% sure about that. Something feels kind of weird about it, but I think that's a pretty good optimization. It's not going to change the official Big O runtime, but it might have a pretty big effect on the runtime and the memory size. The runtime. Just the runtime. Call it buck out if our sum goes down. Maybe. Alright, anyway, continuing on. So for sum is max, and there we go. And then I think we're done. So we can just return the max. Oh geez, this is, I did this in Go. Not today. Alright. Let's see. Is this making sense? Let's try it. One of these days I'm going to get a new mouse. It's going to click when I click it. Okay, so that looked good. I'm not aware of any tricky edge conditions or anything. I already considered negative numbers. JavaScript should be stupidly fine with really big numbers. It'll just kind of work. They didn't say anything about floats. Nope, talking about integer arrays. So I think that's pretty good. We've got a potential optimization. Do you want to try the optimization? Tell you what, let's submit it once, make sure it works before trying to click. Trying to do this. Wrong answer. What? What happened? More details. $47 out of 202. Alright, well. That's a bummer. Doesn't that look like the test input that we just ran this on? Oh, phew. I thought I might have lost my answer there for a minute. The numbers in the note. I don't remember the note, but hey, glad you got the stickers. I'm always worried about them not making them out there. And I'm sure I was probably late on sending them. Sorry about that. Do you remember what those numbers were? I can get a little goofy sometimes when I'm sending stickers. Yeah, copy this. Let's do the test case. So that's the one that they said didn't work? What? I thought we'd test this. Oh, look at that. It said finished. I saw the green and I assumed. 4 and 6. So, hey, 24 is way better than 6. Did I not reset the sum when I changed the digits? No. So for every index, just walk through this. Don't need this anymore. All right. So we start with -2 because we set it here. And then we start looping. Oh, I didn't really think about kind of end cases here. So I don't know, maybe we'll get to that. So we start with -2. That's now the sum. And then we're going to set the sum equal to -2 plus 1, which is -1. It's -3 is -5. -4. Get that right. -30, 03, 01, 13. Oh, geez, I don't know. Was it me that sent it, or was it like Outlaw? -30, 03, 113. Oh, geez, I don't know. If that's a secret code, I don't remember it anymore. -30, 03, 01. Oh, 1 star. No, I don't know what that is. Sorry about that. How do you like those hex stickers, by the way? They're supposed to be able to like slot together as a standard sticker size, so you can make like a cool looking mesh. -4. Then we get sum of 0. So when you get to sum of 0 too, it's like silly to even consider this the rest of the chain, because it's like, why not just start here? I guess I can stop writing sum. Get to -1, 1, -4, and 4. So I mean that looks oops, good to me. The max should be good. So I don't know why I'm typing this out, because we've got our old pal console.log. Dang, I don't remember. $30.03. I don't know. I'll ask Outlaw or Alan about it. Maybe they did something. I will say sometimes I sign stickers, letters as Alan or Outlaw when I send them particularly late. So it looks like one of them is late and not me. So maybe they returned the favor. Life hacks. Oh my gosh, why? Look at this. What is that doing? Oh, what's up, Nico? So just like the name Gavin? Both are cool names. I work with the Nico. Like every time I say, what's up, Nico, I feel like I'm talking to a gangster. What did I do wrong here? Hey, look, it's always going up by -2. What the heck? Oh, look, I'm adding I, not J. Jeez. All right, now it's gonna work. So that was a dumb mistake, and I wasted the submit. I ruined my submit ratio. They actually track how often you submit and how often the answer is actually correct. So feels bad, man. All right, we'll submit this and then we'll try the optimization. Yay, we got it. Okay, so optimization. Basically, if before we do this, or after we do this, if the sum is less than the max, then let's move on. Oh, you know what? Before we do that, let's I want to see more details. Okay, runtime distribution. I want to see where I fit into here. There we go. Here's the normal view. It's kind of weird. So now if I get rid of this and submit again, it'll actually tell me a little bit of stats saying we're faster than 5% of the JavaScript solutions for this one. And we use less memory than 98%. So that's a little hint there. Going to say that people are obviously doing some sort of memoization, and that's why our memory use is so low, but the runtime is terrible. So apparently there's a much faster solution. So let's try this optimization. I think it's going to, I think it's going to drop the speed quite a bit, and it'll still keep our memory use real low. So that should be cool. And then we'll call this baby done. All right. So if our sum is less than the max, that's awesome. Oh man, my Gmail name, the Gmail address I've been using for like forever now, it has the worst name. And when I signed up for it, I just thought it was kind of cool. And now I've been living with it forever. I don't even want to say it, it's too embarrassing. So if the sum is less than the max, it's not really, I don't want to know if the sum is less than the max. I just want to know if I'm moving in the wrong direction. Is that even sensical? Yeah, so it's, I don't know about this optimization, guys. Whew. It's definitely not if the sum is less than the max. It's if the number goes less than our new sum. Let's look at the sample again. Console? Yeah. -2 plus 1, we're at -1. We go -3. Then what I'm saying is once I see -3 and it goes past -1, then I know I can stop including all of these numbers. And what that means tangibly is I could just say increment I instead of J. But what exactly am I saying here when I say that, am I saying that I've reached a new minimum? I'm not sure what I'm saying. Am I crazy? -2, -1, -4. And yeah, you know, I think I might just scrap this optimization because I'm kind of realizing is I don't really understand what I'm saying, and also I don't know that it would work for all negative numbers. So I think what I was kind of really beating around was basically if it's a negative number that I thought maybe I could kind of skip ahead, but I really don't think that's the case. So I'm just going to back this out, and we'll head to the discussion on this, and maybe someone over there will have figured this out, and we'll see. And that was today's problem, by the way, for the 30-day LeetCode challenge. You can still do all those problems, so even if you haven't started yet, there's nothing stopping you. So, yeah. So if j is less than or equal to the sum. Oh, geez, I think you're right. Okay, so if num's a j, right, we need to do that before. Is that right? Less than or equal to the sum. And then we can just continue. No, we don't even need to continue. We can break. Man, I think you figured it out. What did I do wrong? No. If num's a j is currently if it's I needed to this is all, oh man, this is so close. It's almost like, geez. Where's nums a j? Oh yeah, I knew what you meant. But really, I want to know if it's greater than sum in opposite directions. So it's like if it's -4, then that's gonna drop us past 0. So it's almost like if sum is greater than 0 and sum plus, well, I think you got it. That's it. But it's just I have to know there's like something missing. I need to know if it's going to take it lower. What if I say these two? I can't think straight. I'll give it one more minute. The current item we're looking at is going to bring us down past what? It's not 0. Geez, I don't know. All right, I'm giving up. I'm going to go look at the discussion and hope somebody else ironed out that tidbit. O of n solution. So that means they're looking at every number just once. So that O of n solution is going to be way better than the optimization there. So look at that in a minute. I don't want to read any Java. Sure. Ooh, with explanation. All right, so let's look at these guys. Okay, so here's their first answer. It's basically R, so O of n squared. So that's good. Okay, so the second approach, divide and conquer. Many steps can be minimized here, but provided expanded code for someone who's struggling to understand. The heart of the algorithm lies in finding the maximum sum value coming out from the left and right sides. Jeez. Yeah, so glad I didn't type this up. I have a headache just looking at this. Yeah, we're gonna keep scrolling. All right, so Kadane's approach to this problem can be solved in linear time. Prefix array knowledge will be very helpful. Prefix array. What do you mean by that? So max ends, max till scene. So I was initializing these two variables and they loop through a range. So they're looping through the entire thing. If the max at the end plus the current item is less than the current item. So this is kind of similar to the optimization we were kind of going for, I think. So it's basically like trying to find kind of how to kind of explain it. It's basically looking at the minimum information. Looking at this though, I'm glad I gave up because I don't know that I ever would have gotten here. This is slick. So it's looking at a minimum in the numbers, and basically it's able to decide when basically the minimum information I'll look at. I don't really know how else to say it. I can read each individual line and understand, but I'm definitely struggling to understand the kind of the high level description. So I can't give you like a easy sentence on why this works, assuming it does work. Maybe I'll try to find this Kadane person. I guess Kadane is maybe buried in the past. Oh, this is easier to read. Okay, so that was my solution. Kadane's algorithm. So the local, okay, so a local maximum and a maximum for the entire thing. The max for the entire thing is basically my local max compared to my local global. So I still don't understand how they only loop once. Let's say my minimum, my local maximum is whatever's bigger, my current item, or the max local plus local m. So if we kind of take an array, just do I'm not going to work through all of that. So what they're saying is they're going to loop at or they're going to keep a local max and a global. They're going to initialize to the first element in the array, okay? And then they're going to loop through. So starting at 2, say is 2 greater than -4 plus 2. And it is. So now the local max is -2. And then next line is, wow, this is slick. We take a look at the global and say which one's bigger here, -2 or -4. Wow. So yeah, this is kind of what we were beating around the bush for, trying to kind of hint at basically finding a local maximum. And what I kind of had was like half the equation, so we're trying to look at how to buck out, but really it's not just bucking out, it's just looking at local minimums. So this is cool. So if we do it one more time, now we're looking at 1. So I can just look at the local minimum. So it's basically turned it into a dynamic problem where we're keeping like a table of the relevant information. That's slick. I definitely struggle with dynamic problems, and I didn't even consider it here. I didn't even think about kind of going the dynamic route. I need to get there. So this was a good lesson. hopefully you guys enjoyed. And I've got 3 minutes before I'm supposed to start work, so I'm going to get out of here. Yes. All right, so have a good one. Hope you enjoyed.